Guys, let's go over the Benchmark 2 study guide. It says, Kelsey graphed the system of inequalities below. List 3 ordered pairs that would be solutions to the system above. So, guys, anything in this area would suffice. It really doesn't matter which 3 you pick. Let's pick this point. That's 0, 0. That's an easy one. At this point, 1, 1. Look at this point, 4, 2. Any of these would work perfectly fine. Graph the system of inequalities on the provided graph. So these are already written in slope-intercept form. So we're going to look at this y-intercept. That's at 4. So our first point is going to go at 4. Then it has a negative 1/2 slope. So that means down 1 over 2. And that slope continues. So that can keep going. Down 1 over 2. And then we need to draw a line. So this right here determines if our line is open or closed. It is less than or equal to, so that is a closed circle. That's a terrible line. All right. And then we have to decide which side to shade. So because y is less than, see how there's a small side by it? That means down. So if we're on our line and we go down, it means we're going to shade this side. I'm not going to shade it too dark because I need to be able to see. And that's just for the first one. So that's not like the actual shaded area yet. That's just a shaded area for the first one. All right. So the second one, a different color, has a y-intercept of -2. So we're going to put a point down, -2. And our slope is -3. So that means down 3. So 1, 2, 3 over 1. And because it's just greater than, it means a dashed line, dotted, dashed. It's very crooked, I'm sorry. And then y is greater than, so that means if I put my pen anywhere on my line, I'm going to shade up. So it's like all of this area. So the actual solution area, you can erase the rest or you can just shade in the part that's both colors, and that's this part. So this part is the solution to our system. Okay, this one already has them graphed, but they want us to shade the region. So we need these in slope-intercept form because that's what we're used to, which means we need to solve for y. So let's look at this first one right here. So I have 2x plus 3y less than or equal to -6. I'm going to subtract that 2x because I need to get y by itself. That's slope-intercept form. So I have 3y less than or equal to -2x minus 6 divided by 3. So y is less than or equal to, it really doesn't matter what we have over here. You don't even really have to simplify it. It's important is y is less than, and that the y-intercept's at -2. So that means it's this line, the red one. And if y is less than, that means we're going to shade the bottom portion. So for this particular graph, we shade the bottom. And you don't need to shade this yet if you don't want to, because it just wants us to shade the region that is the solutions, and that's not the whole part. That's just for that one. So for the next equation, grab a different color. We have x minus y less than or equal to 5. So I need to subtract x from both sides. So I get negative y less than or equal to negative x plus 5. Divide by -1 to get rid of that negative. So I get y. Remember, you have to flip your sign when you divide by negative. And then that, it doesn't even really matter what we get over here, but it would be x minus 5. What's important is that's y greater than. So for this one, we're going to be shading, if I put my pen on any point on the blue line, I'm going to be shading up. So it's this part. So the solution set is the part that's shaded by both, which is this area right here. And you can actually erase everything else. There we go. Coach St. Pierre is planning to order tennis balls and golf balls. Each tennis ball costs $5. Each golf ball costs $3. He plans on buying at least 30 tennis balls and golf balls combined. He can spend a maximum of $120. So write a system of inequalities that represents the situation. So this one's not easy, but they're going to be somewhere on the front. So when we write a system of equations, we have to think they're giving us the how many tennis balls and golf balls, and then they're giving us the cost of each. So let's let each tennis ball be, just go ahead and say T, the golf ball can be G. So I know that I'm buying 30 total. So one system can be X, not X, sorry, could be T plus G equals 30. Okay. Actually, let's just make them X plus 1. That would make it easier for y'all. So we're going to make tennis balls X and golf balls Y. So we know X plus Y is going to be, if it's at least 30, it's going to be greater than or equal to 30. So the next part says that is the cost. Well, I don't know how many tennis balls I'm going to buy, but I know that they're $5 each. So that's 5X plus, I don't know how many golf balls I'm going to buy, but I know that it's $3 each. That's 3Y. And he can only spend $120. So he has to spend either less than $120, or $120. So there's our two systems. I mean, our two equations, inequalities in the system. And they want us to graph them. So to graph them, we know that we need to give them slope-intercept form. So I'm going to subtract 5X from this one. So I get 3Y less than or equal to negative 5X plus 120 and divide by 3. So I get Y less than or equal to negative 5 over 3X plus, and then I divide 120 by 3, which should give me 40. I'm going to rewrite this up here so it's off of my graph. And I'm going to erase this to get it out of the way. Okay, then for the other equation, I just need to subtract x from both sides. So I get y greater than or equal to negative x plus 30. All right, so I have my two equations. They want us to graph these. So the first thing we have to do is set up our parameters. And the bottom is the x, the top is the y. But our y's, you see, we have to get to at least 120. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can count by 10 on the y. 0, 10, 20, 30. I can't hardly see this. 20, 40, 60, 80, 100, 120, and 40. Okay, so it's all the way up to 150. All right, so if we graph the blue, the y-intercept right here is at 30. So that's right here. And then because the slope is -1, like -1/1, which means we would be going down 1 and down 1/1. So for our x's, we can just, to make it easier, we'll count by tens as well. And note I skipped every other line in the y's. So that's why I only showed 20, 40, 60. They were close together, so it was more difficult. And then this would be 30, 40, 50, 60, 70, so on and so forth. Over 1. And then our line solid. And we shade above. So all of this area is going to be shaded. All right. Then for the other equation, our y-intercept's at 120. That's up here. My slope's -5, so that would be if I went down 5. 1, 2, 1, 2, 3, 4, 5 over 1. And it is solid. And then we would do below. So this right here is actually the only solution to the equation. So we can erase all this. Okay, this one says the EA Theater Club is putting on a performance of Beauty and the Beast. They are selling tickets for $3, and the student tickets for $3 and adult tickets for $5. The EA cafeteria can hold at most 500 people, and the club's looking to make at least 750 for the performance. So they want to start a system of inequality to model the situation, with X representing the number of student tickets and Y representing the number of adult tickets. So this is kind of similar to the one we did to number 3, I believe. So I know that if X is the student tickets and Y is the adult tickets, then that can't be, X plus Y cannot be more than 500 people. So it has to be less than or equal to 500, simply because you can only hold 500 people. And then the other part of the system is going to deal with the cost. So for each student ticket, it's $3. That would be 3 times X. Plus for each adult ticket, it's $5. So it's 5 times Y. And if they want to make at least 750, it has to be greater than or equal to 750. And so I just have to pull out that information. So we did part A. B wants a viable solution. So since we're not graphing it, what we want to do is solve it. So I'm just going to rewrite it to have more room. All right. So to get this in y-intercept form, I need to solve for one of these. I'm just going to go ahead and solve for y, because we have to solve this using substitution. So I'm going to subtract x. Y is less than or equal to -x plus 500. So actually, I let y'all use a graphing calculator, Desmos graphing calculator. So I don't want y'all doing substitution. We're just going to keep Desmos.com. All right, so the video wouldn't let me go to Desmos, so I just went to Desmos. I typed in those equations or those inequalities, and now I can see my possible solutions. So any numbers in this area would work perfectly fine. If y'all mind me, I can show y'all Desmos one more time on Tuesday before your exam. All right, these problems are ones that we actually just did last week. So to determine if the functions are relations, each x can only go to one y. So that was just writing each as our column. So our x's are 0, 3, 5, and 8 for the first one. Our y's are 4, 8, 9, and 12. And when we draw our lines, we have 0 to 4, 3 to 8, 5 to 9, and 8 to 12. So because there's not more than one line coming out of this x, this is a function. So we'll call this one function. All right, so for the next one, if I do negative 2, 2, 5, and negative 2 again, so I don't need to draw another one I already had. Then for my y's, I have 4, 3, 9, and 7. So from negative 2 to 4, 2 to 3, 5 to 9, and negative 2 to 7. So I look in this column, and I do have more than 2 lines coming out of one of these, so it is not a function. Okay, for the next one, I have 6, 6. Okay, so I only need to write one time. Then negative 8, negative 10, negative 12, and 6 is going to all of those. So I'm looking in this column. 6 does have more than one coming out of it, so it is not a function. And the last one, 1, 2, and 3. And then I only have 3 as the y. So 1 goes to 3, 2 goes to 3, and 3 goes to 3. Don't let this confuse you because I'm only looking at this column. There's only one line coming out of each of these, so this is a function. Right. Our relationship is shown below. Which of the following values of x would result in a relationship not being classified as a function? Okay, so let's write what we have. We have the 4 with a negative 3, a 1, and something else. Okay, so remember, the thing is we don't want if more than one line's coming out of any of these, it's not a function. So that means this x has to be one of these numbers. So we would select 4, negative 3, and 1. You could just try all of these if that's confusing. So you could have, if this was 4, you could go ahead and write it out. Say 4, negative 3, 4, which I wouldn't write again, and negative 5. I'm sorry, 1, not negative 5. So then when you write all of these, you have 5, 7, 9, negative 5. 4 would end up going to 5, negative 3 to 7. 4 would also go to 9. So you have more than one coming out of this. And you could do that with all of them. All right, identify the functions. So again, the easiest one to do without even looking at it very much is this because it's already fixed for us. Is there more than one line coming out of any of these? No, there is not. So this is a function. I'm just going to put an effort in. Okay. For this one right here, it's easiest to do a mapping. So I'm just going to do 0, 3, negative 3, 2. And then I have 2, 4, negative 2, and I don't want to write 4 again. So I have 0 to 2, 3 to 4, negative 3 to negative 2, and 2 to 4. Do I have more than one coming out of this? No, I do not. So this is a function. Okay. For the graph, though, we don't have to plot this one, so we can just do the vertical line test. So there anywhere that my line touches that twice? Yes, there is, all in this area. So this is not a function. We can do the same thing down here to edit the graph. We can either make a mapping of these points, because like I know this point right here is -4, 1. But even easier is we can draw lines and see if we go through 2 points, which we do here and here. So this is not a function. And then this bottom one, it's easy to do a mapping. So my domain is 2, 4, 11, -21. And then I have -5, 31, -11, 3. It's 2 to -5, 4 to 31, 11 to -11. Maybe here. So I do not have more than one coming out of this, so this is a function. Okay. Jane has decided she wants to sell bracelets to raise money for St. Jude's Children's Hospital. The function M of B is equal to the amount of money in dollars she earns for selling bracelets. At the end of her first day selling bracelets, she's 57. M of 36 equals 57. What is the total number of bracelets Jaden sold on her first day? So let's look. It says the function M of B is equal to the amount of money in dollars she earns for selling B bracelets. So B is this right here. So if you look at this function, this is B. So the amount of money that the number of bracelets she sold is 36. So this was simply reading the function notation. Whatever's in parentheses is what was right here. And the last one for this review. Peyton starts to walk from her house to the store. The distance she travels walking in yards is equal to the function f of t, where t represents the number of minutes she has been walking. Peyton walks from her house to the store. Before she leaves her house, that's f of 0. And when she reaches the park, f of 15 is 450. So we just need to determine what's true and false about this function notation. So it takes Peyton 15 minutes to reach the store. Well, it says when she reaches the park, f of 15. So this is the only place we see 15, and it's what represents in parentheses, which is t. And t represents the number of minutes. So it was 15 minutes to get to the park. So this is incorrect. Okay. The next one says the store is located 15 yards from Peyton's house. Again, the only place that they have 15 is right there. So this is actually incorrect because the 15 is for time. It's nothing to do with distance. Then the next part says when Peyton is at her house, she has walked for 0 minutes. Well, it just says before she leaves her house, f of 0, and that 0 is the time in minutes. So that is